Hello, welcome to another exciting episode of Fun with Math. So this is a recap on the area equals diameter squared exercise where we were talking about conductor sizes. And this is Unit 11, page 287 to 289, deals with this scenario out of Delmars. So any wire has so I did a little lesson on the surface area volume. You might want to review that lesson that dealt with circular mills, square mills, that sort of all tied into this exercise. So we have circular mill area, so we have the diameter, and the diameter expressed in mils. So 1 mil is equal to 1/1000th of an inch, and that is the diameter of the wire. So the diameter of the wire in its smallest point, that's the reference in Delmars, is 1/1000th of an inch. So the example here, if we had 500 mils, for example, that would be 500 out of 1,000 mils, which would be half an inch. So the diameter that we're squaring, the area equals the diameter squared, that is the diameter expressed in mils. We aren't squaring, so this diameter we'll say is half an inch. It is also known as 500 mils. Because 1 mil is 1/1000th of an inch, well, 500 parts of 1,000 is half of that. So it's important to understand where I get little hiccups with students is understanding what it is you're squaring. You're not squaring the inch value, the 0.5, or you're going to end up way off there. But so the 0.5 has to be converted into mils. And to do that, we just times this by 1,000. So we take 0.5 times 1,000 gives us 500. And so on. So the area equals diameter squared. The diameter is expressed in mils, right? The circular mill. And when we square this, that's where we get to the area. So we have 500 mils. But when we have 500 mils squared and we end up with 250,000 circular mils, as soon as we square it, that's where we end up with the area. It's this times this one dimension times the other dimension is where we get the square, and that's where we accumulate the area. So if we have 250,000 circular mils, so that's the circular mill area. So 250,000 C mils is also known in our code books, or in general, as 250 MCM or 250 kc mil. MCM being the Roman numeral for 1,000, cm being circular mil, or 250 kc mil, where k is metric for 1,000, and circular mil being just expressed slightly different, still with the cm, but circular mil. So on our cables, we'll have 250 NCM stamped on it, or they'll have 250 kc mil. And remember, there's a lot of information that are stamped right on our cables. If it's NMD or TAC or whatever, there's always all sorts of information, the voltage rating, the temp rating, all sorts of things. So if we continue, just a couple of questions here. What is the area in circular mils of a wire with a diameter of 500 mils? So notice now this is already converted from inches into mils. If I wanted to ask how much 500 mils was it an inch, we just divide this by 1,000. So 500 mil squared gives us 250,000 circular mils, otherwise known as 250 MCM. And to elaborate on that, what is the area in circular mils for a wire that is 0.5 of an inch? So, like I said, step 1, convert inches to mils. So we have 0.5 of an inch times 1,000 gives us 500 mils. And then we can carry on, as we did in the first step here, 500 mil squares gives us 250 kc mil or MCM. So if we do this in reverse, so the question, what is the size in mils for a 250 MCM wire? Well, when we square, to undo a square, we require a square root. But 250 MCM, again, you got to watch here because this is an abbreviation. So we don't want to, and again, I get little hiccups here sometimes. I'll get 250 square rooted. You have to make sure that you convert your MCM into the actual C mils here. So 250,000 C mils, that's what we square root, and we get down to 500 mils. What is the size in inches for a 250 MCM wire? So we just end up with one extra step. So we've got 250 MCM because we want to go down to inches. Here I was asking for mils. So here I'm asking for inches. So we have to take that extra step. So 250 MCM, convert it to C mils there. Square root it. Gives us 500 mils, divide that by 1,000 gives us half an inch. Now, this is just a nice number. The numbers are nice and clean, so that's why I use it as an example. But the system stays the same for all calculations. And that's sort of how to create this question. So when you go forward and reverse through these, the reverse process, or when you start from the, well here. So we got 350 MCM, gives us 350,000. Square root gives us 591 point. Now look at all these decimals here. I just want to sort of notice. It's a little tough to go in both directions with these questions. So 591, so we got, if we just take it to 2 decimal places, or 3 decimal places, divide that by 1,000. Now this is the mils, right? All we've done here is converted this. This is the mil area. We're not into inches yet. It's a 3 decimal places divided by 1,000 gives us this number. So if we just take 2 here, and we just don't go to 3 decimal places, we divide it by 1,000, we get this number. So if I just took these values and I said, and I asked, well, what is the MCM if the diameter is 0. And I just take it to 3 decimal places times 1,000 gives us this in mils. And then when we square this, we don't quite end up with 350 MCM. And then if we take even less decimal points, times it by 1,000, gets us into mils here. We square the mils, gets us even further away from 350 MCM. So many decimal places are required for this type of question when I'm asking it from this perspective here, looking for MCM. So the 0.5 of an inch works real well for the 250 MCM, but everything else gets kind of nasty. So I just thought I'd have a little conversation on that. So here's a few questions. Questions you should be able to answer. We talked about this in class, and sort of how everything is relative. So where does AWG end and MCM begin? So I got the answers coming up. I'll just or just pause the video, write these down or whatever, and then I'll put up the answers. So where does AWG end and MCM begin? In other words, what is the last AWG size? What is the first MCM size? For copper and aluminum wire, will the AWG or MCM sizes be different? In other words, is a 250 MCM copper larger than a 250 MCM aluminum? If copper and aluminum AWG or MCM sizes are the same, which one is allowed to carry more current? These are very basic but fundamental questions that should be obvious to you at some point, or make a point to make them obvious. And what else do we have here? What is the diameter in mils for a 1,000 MCM wire? So just a couple of basic questions. What is the diameter in inches for a 750? So notice here, I asked for mils here, inches here. What size MCM for a wire that is 1 inch in diameter? So pause the video, and I'll put up the answers in 3, 2, 1. So there you go. Study those, and we'll carry on to the next here. Area equals diameter squared meets art equals K times L over CMA. So there's kind of a relationship here between these two calculations. So the thing to understand about the K factor, the K is 10.4 ohms, but in Delmars, it's relative to 20 degrees ambient temperature. So this is always varying based on the temperature. But if we take, say, a number 14 AWG, and again, this is in Delmars, in the tables you can see the AWG sizes there. Number 14 is good for 4,107 circular mils, and that's the circular mil area. So if we go through the same process and we square root that, we end up with 64.0858 yada yada mils. Now if we take that and divide it by 1,000 to get into an inch, we have 0.0648 of an inch, which is roughly 1/16 of an inch. So if we take this number, times it by 16, you'll have roughly 1 inch there. And if you check on a tape measure, and you take a number 14 gauge wire and stick it in there, you'll see it fits right in that slot from 0 to 1/16. So if we compare square area to square area, we have 1 C mil and 4,107 C mils. Gives us a ratio from 1 to 1. So 1, which is the ratio of 1 C mil to 4,107 C mils, gives us this number right here. Now, if we just take R equals K times L over CMA, and then just for example here, so we'll use the 14 gauge wire, we'll just use 1 foot. So if we take 10.4 ohms, and again at 20 degrees Celsius, times 1 foot over 4,107, we'll get this number. But if we take the ratio of 1 C mil to 4,107, which is what we have here, which is this number right here, and we apply it to this value, we get the same number. So there's a little hidden relationship going on. Now the 10.4 ohms does represent the 1 C mil. So I just wanted to sort of express here that there's a relationship here when applied, and if we can apply this to any value, because in residential they give us a different value. And here, so residential wiring, page 7879 deals with voltage drop. So in Delmars, the K is 10.4 at 20 degrees. Residential wiring is 12 ohms at 75 degrees. So there's a variable right there with your K value. But the one constant will always be this relationship right here, the C mil to the conductor circular mil area. So at 20 degrees, 10.4 gives us 0.0023. And if we take the relationship and apply it, we get this number. At 75 degrees, so this is relative to the residential wiring, 12 ohms, 4,107, we get this number. We take this relationship and apply it to the 12, we also get the same number. So, a couple questions just to wrap this up here. What happens to the resistance of wire when the ambient temperature increases? What happens to the current carrying ability with an increase of resistance? So pause the video, get your answers down, and I'll get you the answers in a couple seconds here. And there we go. Increases the resistance and decreases as the resistance increases. So there we go. That's about it for that. And so this is meant to go along with your handouts that will be in the CAMS document folder.